guys, welcome back to my channel. I do lead code problems, tech related stuff. And today we're gonna solve another lead code problem called majority elements. It's an easy problem, but there's something interesting about this problem. This one is one of the most asked question in the interviews by the interviewers. So we're gonna try this one. Given an array of nums of size n, return the majority element. Majority element is the element that appears more than and divided by 2 times. You may assume the majority elements may exist in the array. So basically majority element is, let's say this is the array we have, and then 3 2 3. So in this case 3 is the majority element. Same here, so 2 2 1 1 1, and then 2 2. So 2 is the majority elements. And then there's a follow-up. So could you solve the problem in linear time and in order of one space, so without using anything? But first we're gonna try our first approach first, normal approach, which will be linear time, but it will not be in order of one space. It will be in linear space as well. So the first approach is we're gonna use a hash map. So we're just gonna add all these numbers into a hash map. Let's say we add trees into the hash map. We put 3 into hash map, and then we put we put 3 as a key, and then we put value as a counter. So how many times we see them. Let's say 3 is the key, and then we just add 0 first as a value for 3, and then we go to the next, also add 2, and then we go to the next, and if we see 3 again, we're gonna increase the 0 to 1, so we know the frequency of it. Okay, and then we just try to see which one has more frequency than n divided by 2, and that's the majority element, you can say. Okay, so let's use a hash map of integer map equals new hash map. Okay, and then you're gonna use enhance for loop int num. Let's use num. Then we're gonna use nums from the array. Then we're gonna just add map dot put. At that put we're gonna put the num, and then we're gonna the value we're gonna put gonna be the frequency, right? So we're gonna try to get the frequency if it's already in there. So we're gonna do map dot get or default, which is we have to put num. If it already have the value, we just get that value, and then if it doesn't have value, we make it 0 as default, and then we add 1 to it. So okay, and then what do we gonna do next? We're just gonna check if map dot get num, which will give the frequency if it's greater than nums dot length divided by 2. So if it's more than, if the elements appears more than num divided by 2 times, that means it's a majority element, right? So we just check if nums.get will give us the get num will give us the frequency of that number, and then we're going to compare it with if it's greater than divided by length divided by 2, then it is the majority. Then we just return the number, because we have to return the actual number and not the frequency of it. And then this is the case where, just return something if we don't have it at all, but it will never reach here because it says you may assume that exists in always exists in the array. So let's try to run this. Okay, accepted, and we can do submit. So 15 milliseconds. So the time complexity of it, it's order of n, it's linear, but the space complexity is not the constant like in the description, right? We're not using the constant space, we're using linear space as well. So we're gonna do another approach called, this approach is called, I just have it here, it's called Boyer-Moore voting algorithm. So it is used when you want to find like a majority elements in an array or something like that. I've never heard of this one also, but the runtime complexity is order of n, same like the previous one we did. But the space complexity is better, so it's order of 1. So let's implement that. Let's get rid of this. There's the int candidate equals, let's put it as the first element of the array int count equals 0. So how it works, it's kind of a little bit confusing to explain, but I understand. I also kind of understand it. So here's the thing. So let's say this is the num, right? This is the array. So index gonna be 0, num gonna be 2, candidate gonna be 2, let's say, because we assign it as the first one. 2, we're gonna increment the count by 1. So set 2 as a candidate and count will increase, okay? We will increment the count. And then it will go to the next. Now count is 1. And we go to the next element and we're gonna check if the candidate is still it's the same as the num. Okay. So if it is same, then we're gonna increment the count. The candidate is still 2, right? So then this is 1. So since if there's a difference in them, we're gonna reduce it by 1. Okay, we're gonna do a difference. We're gonna reduce the increment. If there's a difference again, we're gonna reduce it to 1 again, and once the count becomes 0, we're gonna assign it to num again. So so it just keep track of the which one should be the most. I don't know if I hope it makes sense. Kind of, if you don't know, like, you can just go and make some research about this. It's called Boyer-More voting system. Okay, this algorithm. So we're gonna use for int num of nums. Then so we just gotta do if, right, count equals 0. So if count equals 0, we're gonna set the candidate to candidate equals num. So this one. Okay. So why do we set it to num? It's because let's say we got the count to 2 and then we decrement it and then it got to 0 again. Then that means if we see more of that number, then we need to add, right? So we just change the candidate to that number and then we just start increment the count again. So it'll become 1 and it'll become 2. And if we see different elements again, we're gonna reduce that count to from 2 to 1, then to 0, just like that. And then once it's 0, we just change this. Okay. So for this, we're gonna do count plus or equal to if candidate is equals to num. That means we are consecutively seeing it, right? We are consecutively seeing that number. If candidate is equal to num, that means we're consecutively seeing that number. So that means we can add 1. Otherwise, we're gonna decrement it by 1 because count plus. So that's all. And then we just return candidate. I suggest you to go do a research about a little bit of research about Boyer-More voting algorithm, which is quite fascinating, to be honest. Just keep track and then keep reducing. You already know if it doesn't exceed 2, so it cannot be majority anyway. So very fun. So we can run this code and let's see the results. Yep, working perfectly fine. Submit. You see it's much faster. And then this actually fits the description. So it's linear time complexity. We only have a loop once. Okay, we have to loop it only once to the whole array. And then order of 1 space, we didn't use any arrays or lists, so we just had this constant space. It's a constant space, guys. So that's all for today. And if you have any problem next, you can let me know in the comments. And please subscribe if you like the videos I'm doing. Thank you very much. Have a good day.